Solve by graphing. Y equals 2x plus 4 and 4x minus 2y equals negative 8. If we look at the first equation, y equals 2x plus 4, we can see that this is already in slope-intercept form, so we might as well use that to graph it. The slope is the coefficient on the x, which is 2. We can write this as 2 over 1 if we want it to be in fractional form. And then the y-intercept comes from the constant term, which is 4. So that's going to be 0, 4. So our starting point is the y-intercept, 0, 4. And the slope is 2 over 1. So we rise up 2 and run to the right 1. We rise up 2, we run to the right 1. And if we want to have more accuracy in the other direction, we can go oppositely. We can go down 2 and to the left 1, down 2 to the left 1, down 2 to the left 1, etc., etc., etc. And we end up with our line. It's going to look something like this. All right. Now let's look at the other equation. We've got 4x minus 2y equals negative 8. This one isn't in slope-intercept form, and so I'm inclined to use the intercept method here. To find the x-intercept, we're going to let y be 0. If we let y be 0, then this is going to be 4x minus 2 times 0 equals negative 8. Now anything times 0 is 0, so that second term is going to go away, leaving us with 4x equals negative 8. And if we divide both sides by 4, that's going to give us x equals negative 2. So we go on the x-axis and we look for negative 2, which is right here. It happens to be the same intercept, the same x-intercept as the other line. So we might almost be tempted to say that this is the solution, but let's continue. Let's figure out what that line actually looks like. We've only found the x-intercept so far. Now we're going to find the y-intercept. To do that, we have to let x be 0. Now if x is 0, then that's going to give us 4 times 0 minus 2y equals negative 8. But anything times 0 is 0, so that first term is going to go away. We've got negative 2y equals negative 8. To get y alone, we divide both sides by negative 2. That gives us y equals positive 4, because a negative divided by a negative is a positive. So our y-intercept is positive 4, and if we look on the y-axis and put that there, we can see that it's the same y-intercept as the other line has. These lines have the same x and y intercepts, and so it's going to actually be the same line. Both of these equations end up giving us lines that are right on top of each other. They are the same line. So we have to figure out a way to say what the solution is going to be. Now, it's not going to be all real numbers. Sometimes students think that in a situation like this, we should say all real numbers, because the last one was no solution. But that's not appropriate here, because solutions to equations that have an x and a y aren't going to be numbers, they're going to be points. They're going to be ordered pairs. There's going to be an x value and a y value. So we aren't going to say all real numbers, but we're also not going to say all points, because if you look at the x and y plane, there's a whole bunch of points that aren't actually on that line. So it wouldn't be appropriate to say all real numbers. It wouldn't be appropriate to say all points. Now we have to figure out what to say, and there's different answers depending on what book you're using, what your instructor wants, etc. The first thing to note is that if we look to see how many solutions, there are infinitely many solutions. Infinitely many solutions. Because every point on that line is going to be a solution, and there are infinitely many points on that line. So that means there are infinitely many solutions. Now in my classes, that is acceptable for an answer. We don't get more specific. But in some classes, instructors want their students to be more specific. Some people might put for a solution all points on the line y equals 2x plus 4. Now, that's actually more specific, because if we just say infinitely many solutions, it tells how many solutions there are, but it doesn't explain where they fall on the xy plane. But if we say all points on the line y equals 2x plus 4, that is a more specific answer. So some instructors might want that. There's an even more kind of technical way to write this. If we want, we can put this in set builder notation. And if you've never seen set builder notation, I don't want you to worry about this. This is not something that is necessary in my classes. But the solution here is the set of points x comma y such that the point is on the line, which means such that y equals 2x plus 4. This is something that is outside the realm of what I usually teach, but it is something that is done in certain classes. If you have an instructor who wants to go a little bit further or be more specific, you might encounter this. But if you've never encountered something like that, don't worry about it right now. We're just going to stick with infinitely many solutions.